Now, configuration-wise, because it's policing, this feature makes use of the MQC syntax, which is going to be like any regular policing configuration. You're going to measure traffic of RIP, RGRP, BGP, whatever, through the use of class maps and ACLs. So either class maps with match protocol, either ACLs which measure traffic in an ACL and then call the ACL in a class map. Then you define the action, the policing, through the use of policy maps, and you call in the policy map the class maps. So for which traffic do you want to police and how do you want to police it? And then enforcement, activation of this feature is done through the use of service policy, but you use a service policy, which means applying the policy map not under the physical interface of the router, but under the control plane virtual interface. So you see, it's easy once you understand I'm doing this today because on the other days I'm just gonna move on showing you when making you understand the technology and showing you how it works. But today I'm going to take time, couple of examples to again make you always understand the technology and think about it. Because you see, it's easy once you understand how it works. And then you understand that the naming convention tells you exactly what it does. Policing, also configuration-wise, is going to be a policing configuration. It's just that you apply the policing function in a different place, under the control plane virtual subinterface. And as you're going to see, the command is going to be control plane, and then you apply the policing function in there. So it's way easier rather than looking to the commands and then trying to memorize the commands, which is useless because you don't know why those are in there to begin with and what they achieve. Verification. You verify the configuration, show run class map, show run policy map. Then once you apply the policing, control plane policing, you verify policy applied and statistics, which show control plane aggregate features and counters. We're going to see that the aggregate keyword is being used because we're going to go next to control plane protection. That feature divides that virtual control plane interface into multiple subinterfaces. So that's why the aggregate keyword makes sense, because with control plane policing, everything is controlled by a single virtual interface, which means it aggregates all control plane and measurement plane traffic destined to the router or initiated by the router. So again, the command makes sense. So you're going to say, show me the control plane aggregate features and counters. If you want detailed statistics about traffic being allowed or dropped per your configuration, it's going to be a regular show policy map command. But because, I mean, let me ask you something. When you apply QoS, you say show policy map what, for example. So when you apply a QoS function, you say show policy map what command. What follows up after show policy map? So you say show policy map correct POS interface, right? You say, show me the policy map applied on whatever interface, correct? So there we go. Because this policy map is now applied on the control plane interface, it makes sense the command is show policy map control plane and a direction, right? So it's the same command. It's a regular MQC configuration and MQC verification, which again is not different at all. It's different because you put a control plane keyword in there. No, because I apply the policing to bring in that virtual intermediate virtual control plane interface who controls traffic destined or initiated by the router. So it's the same command, show policy map, but now for the control plane virtual interface and in or out. So it's the same command. So you don't have to memorize things out. There's a question from Piyush. If no route, then packet will not be safe switched and will hit the CPU, right? Correct. So safe switching happens if the router doesn't have to do any kind of modifications to the packet. So it can just, switch it, route it, or switch it, depending if it's a layer 2 or layer 3 device. And of course, if the router can or the switch can actually switch or route the packet. Because if it cannot route the packet, it's going to be punted to the CPU, because by design of IP, when I cannot route a packet, I have to send back an ICMP unreachable, and any messages generated by the router, it means that the CPU has to generate that. So it means that that packet, which was not routable, actually was CPU switch or process switched, because the router had to generate the ICMP unreachable message. Okay, let's go to the configuration part now. So router 2 NAS8V, or router 3, let's pick router 3. Router 3 NAS8V should have an EIGRP neighborship in there. Let's confirm that per this diagram as well. Router 3 NAS8V should have an EIGRP neighborship. So what I'm going to do is I'm going to go on router 3 and do a input policing to limit the number of EIGRP packets. And of course, in production network, you don't choose those values randomly. You have to understand how many connections, how many EIGRP neighbors that router 3 have, how fast do the router speak EIGRP based on your configuration, and then you're gonna know with what value to end up in your configuration, how many packets per second should the router receive under normal conditions. Let's go on router 3. Confirm it is a neighbor with AS8V. Show IP EIGRP neighbors. It is a neighbor with, on that interface, with AS8V and also with router 2. So per this diagram, router 3, it's an EIGRP neighbor with both AS8V and router 2. So let's follow up on those steps. So match on the traffic, class map, name it, let's say, control plane policing EIGRP. I'm not sure if it supports Mesh Protocol EIGRP, this code. If it doesn't, we have to configure an access list. Show Mesh Protocol EIGRP. It does support that. Exit. Then we say policy map, PMAP for control plane policing. I call in the class map, and I say police, let's say 100 packets per second. Of course, you can police rate, and then of course you can put packets per second, or in some cases you can put bits per second. Police rate, let's say do show run class map to make sure I match the proper class map. Do show. Of course, be careful that by default the class map has a match all type, which means an end between the conditions. Do show run policy map. So police rate 100 packets per second. Confirm action transmit, exceed action drop. So per this policy, I'm gonna tell the router if you exceed 100 packets per second of EIGRP, if you allow 100 packets per second of EIGRP, but not more than that, drop. Exceed action drop the what is above 100 packets per second of EIGRP. Exit. And then the last portion is going to be control plane host. So I go under the control plane virtual interface, and then I apply the policy map with a regular service policy command. Service policy PMAP CPP. Service policy, of course, direction input PMAP CPP. It has, based on the code you're running, it has some restrictions in the Mesh protocol. So let's do this. Let's match EIGRP in an access list. IP access list, ACL, EIGRP, and I'm going to ACL IP access extended, ACL EIGRP, and say permit EIGRP any. Then do show run class map. So based on the code you're running and on the platform, some match statements are not supported for control plane policing or protection. So let's say no Mesh protocol EIGRP, and let's say match access group name and the name of the ACL. So I'm matching EIGRP via an ACL, not via mesh protocol. And now if I go exit and I say control plane and service policy input, put it again, it should work this time. So now if you say show control plane aggregate features, it's going to show that control plane policing was activated today. Counters is going to show you a basic overview of how many packets have been processed, how many of them have been dropped, how many of them have been with errors, because it also protects against, let's say, malformed packets. So 20 of them have been processed, so I have matched the confirm action, 0 have been dropped, none of them have matched the exceed action, and 0 of them have been errors. And of course, to see the detailed show policy map, control plane input. So you see here that we have on the control plane virtual interface, we have this policy map applied, which for class map of EIGRP, which matches on EIGRP, which says I allow 100 packets per second inbound, 24 bursts, and confirmed 49 packets. It means that the 49 packets of type EIGRP that have been received have not exceeded the configured rate, and dropped none of them because I don't have enough EIGRP packets being received by the router to drop those packets in there. And of course, everything else is going to match on a class default, which doesn't have any kind of rate limiting by default. Like for example, one common use case would be that you just use the class default. Like for example, if you just want to make sure that the router CPU is not overwhelmed, you may configure control plane policing just by going on a class default and saying all traffic destined to the router should not exceed, I don't know, 50 packets per second. So you have to know how many packets per second can the router sustain in the CPU in the control plane part. So then you go on a class default and you say police rate 200 packets per second. You don't care what is the type of the control plane packet, EIGRP, BGP, whatever. If that limit is exceeded, you're going to drop everything which is over extra, which because you know that if something is above 200 packets per second, the router is going to go high CPU and you may lose the router completely at that point. There's a question from Piyush. In production network, how can we make a good guess on total EIGRP or any routing protocol traffic? So there is no guessing in there. First of all, you have to know what is the limit of that router. And the router has limits on the control plane part on the CPU based on type of traffic. Like given model A, so it depends on the router model to begin with, and then it depends on the type of traffic. If you take one router, let's say router 2921, that router may sustain 1,000 EIGRP packets per second, but only 500 OSPF packets per second. So it depends on the router model, and then it depends on the traffic type. So the only way to actually understand this has to do with the platform limit basically. The only way to know what is the platform limit is actually you ask Cisco. If you work for a Cisco partner, you ask Cisco and they should be able to provide you with a lot of, not proprietary, but confidential information of a specific router, what is that router's, let's say, limit, or you do testing, you use a testing, let's say, solutions, and you hit a router CPU with 50 EIGRP packets per second or 100 and see when the CPU spikes high enough. And that's how you define, what the limit of that router for that protocol is. So you know that if that router receives more than 500 EIGRP packets per second, is not good. The router CPU is going to be overwhelmed, so I don't want that to happen. So it's not easy to identify what is the router's limit. It depends on the platform and it depends on the protocol type, but you can find it in there. So, and in general, what you're going to do is that in general you're going to not, let's say, configure a limit based on your network, but in general what I've commonly seen in production networks is that people put in there a limit of EIGRP and BGP and R packets, high enough to make sure that just only not to. So what I'm trying to say is that in production networks, most cases what I've seen is that I'm going to put in there a limit for EIGRP, BGP, and R packets just to make sure that I don't overwhelm the router CPU. So if you find out from Cisco by testing that the router supports, as I said, 1,000 R packets per second, then that's going to be your policing limit for R packets. Because you know that if a router receives more than that, it's not going to be good, because the router CPU is going to go high sky, and that's a bad thing. A question from Matthew: Christian, is both your class map and the default both active, or did your policy map overrule it? So like in any kind of policy map configuration, you have a class default which matches on the remaining traffic which you haven't matched in your configured class maps. So what this means, so this shows up in here because that's a regular built-in behavior of the iOS code. And it makes sense because, as I said, a traffic which is not matched by your class map is going to be matched by this class map. But by default, the default class map doesn't have any kind of policing rules in there. It's just going to be matching on every other traffic. Like as you see here, I see 3 packets matched in the class default, 20 packets matched. That's whatever else traffic goes to the router's control plane or management plane, which is not EIGRP in there. So both of them are active clearly, and there's any kind of policy map, the rules are inspected top down. So because this is my service policy applied under the control plane virtual subinterface, then when a router receives, and it's in the inbound direction, when a router receives a packet destined to himself, what it's going to do is going to parse top down. It's going to parse top down each class map and stop on first match. It's going to parse the first class map and it's going to say, okay, this class map matches on what? On EIGRP. Is this traffic that I received EIGRP? If yes, then what is the actions I should perform against EIGRP packets? If the traffic is not EIGRP, then it's going to look in the next class map, which is going to be class default. And as the name states, class default matches by default on all remaining traffic not matched in the user configured class maps.